we use finding infraction point. We let second derivative equal 0 and solve it and get those numbers. And then the number makes second derivative equal 0. You have to check. For example, if c is make second derivative equal 0, then you check to the left and to the right. If second derivative is different sign, change from positive to negative or from negative change to positive, that means concavity changed. Concavity changed. And at that point is the infraction point. So that's infraction point. So like question, we go back to question 2 and 3. Find out infraction points. First of all, this is sales is S. X is advertising fee. And this sales is depend on X advertising. And find the infraction points. That's a concavity changed. So we need to find first derivative and find second derivative and let second derivative equal 0, solve for the x. And then check to the left, to the right of that x. If different sign, then it is a infraction point. So first derivative, negative 0.02 times 3 is a negative 0.06. X to the power 3 minus 1 is x squared. Plus 1.2 times 2 is 2.4. X 2 minus 1 is x to the power 1. 300, take derivative is 0. And then from first derivative, double prime, take derivative again. Take derivative, get second derivative. You got negative 0.06 times 2 is negative 0.12. X to the power 2 minus 1 is x to the power 1. Plus 2.4 times 1 is 2.4. X to the power 1 minus 1 is x to the power 0 is 1. So you got 2.4. And let this second derivative equal 0. Negative 0.12x plus 2.4 equals 0. Solve for the x. Move this over, divided by 0.12. So here move decimal point to the right 2 position is 12. This decimal point move to the right 2 position, got 240 over 12, which is you times 100 both sides. Times 100 both sides. Move decimal point to the right 2 positions. So get 240 over 12, get 20. 20, then you check the sign. If to the left of 20 and to the right of 20 have different sign, then that's infraction point. If the same sign, both are positive or both are negative, that's not infraction point. So you can check 20, plug into second derivative. If less than 20, and then you can use like 10 plug in, you got negative 1.2, add 2.4 is positive, 1.2 is positive. Second derivative is positive. And then like 20, like 30, you plug in here into second derivative in x, you got negative 3.6, add 2.4 is negative. Negative 1.2 is a negative. So it's less than 0, different sign. So that is infraction point. And then you have to figure out that point. Y coordinate also, because you will insert in point. So it's S of x use 20. 20 means 20,000. 20, it's x is in 1,000. 20 plug into original function. 20 cubed plus 1.2 times 20 squared plus 300. So negative 0.2 cube. So have 3, 0. 2 cube is 8 plus 1.2 times 20 times 20 is 400, add 300. And this time together is 16 3 zeros, 2 decimal point. So it's cancel 2 0, get net 160. And this time together, 1.2, get 4800, 1 decimal digits, get 480. Then you add together is 620. 620. Then, because word problem, you have to answer with units. You will say, inflection point is when spend. 20 means thousands. X is in thousands of dollars. So it's $20,000 on advertising the product. It creates the sales. The sales is $620,000 of sales. But finally, you have to explain it and put the answer in real words problem. Because real words problem, and put the answer in real word. It's not just math. It's not just say numbers. You have to put down the units and the meaning of its meaning for each number. It means 20,000 is for advertising fee, and 260,000 is for sales. And question 3, the total sales S of Canon Precision Instruments is related to the amount of money X that Canon spends on advertising its products by the function. So the S is function. This time the degree is 3. Cubic polynomial function. And the S is sales. X is advertising fee, measured in thousands of dollars. Also find inflection point of the function S. So how to find inflection point? Take first derivative, then take second derivative. Let second derivative function equal 0, and solve for those X and get solution. Get solution and check to the left and to the right of second derivative if a different sign. Then that is the point of inflection. So first of all, you take first derivative. 3 times negative 0.002 is negative 0.006 x. 3 minus 1 is x squared, plus 0.6 times 2 is 1.2. 2 minus 1 is x to the power 1, plus 1 x take derivative is just 1. And the 500 take derivative is 0. Then take second derivative. Take second derivative. So we got net 0.06 times 2 is net 0.012 x plus 1.2 times 1 is 1.2. 1 take derivative is 0. Let second derivative equals 0. So it's a negative 0.012 x plus 1.2 equals 0. Move over, divided, got 1.2 divided by 0.012. Then you move decimal point to the right 3 positions. So move 1, 2, 3. So it's 1,200 divided by 12. Cancel, get 100. And then check. 100, check this second derivative function. The number less than 100 you plug in here. For example, like you can put less than 100, you can put like a 60 or 50, put it in, and add 1.2 become positive. Positive, greater than 0. And if you let number x greater than 100, for example 200, you plug it in, then add 1.2 become negative. They are different sign. So that's x equal 100 its infraction point, and you have to figure out their function value s of 100. So 100 plug into original function, negative 0.02002x, x is 100 to the power 3, plus 0.6 times 100 squared, plus x is 100 plug in, plus 500. So this one, you figure out it's 1 to the power 3. Total has 6 zeros. 6 zeros. Then times by 2. So you got 6 zeros. 1, 2, 3, 4, 5, 6 zeros. Then here 1, 2, 3. 3 decimal digits. So you got 2,000 and the negative 2,000. Add this one. This one is a square, is 1 with 4 zeros. Times 0.6, you got 6. 1 decimal digit, so this 1 zero cancel. You got 6,000. You can use calculator. And plus 100 plus 500 and combined. So this 6,000 minus 2,000 is 4,000. Add this, add together is 4,600. Then you got to answer in the real world situation. So infraction point is when spend $100,000 on advertising, it creates sales is 4,460,000. So put 3 more thousands. So you got 4,600,000 of sales. So that's we go to question 4, 5, 6. We done. Now we go to question 7 and 8. Question 7. It's we call optimization questions. Optimization question is either maximizing or minimize. Is application problems. Question 7. A man wishes to have a rectangular shaped garden, this rectangle shaped garden, in his backyard. He has 100 feet of fencing with which to enclose his garden. So if this is the garden, the fence total, which is the perimeter of this rectangle, is 100 feet. Fencing this garden, this area. And A, find the dimension for the largest garden he can have if he uses all of the fencing, use all of 100 feet. Find out the largest, find the dimension, make largest garden, which is the largest area. So we need to figure out the area functions. So dimension, question asks you dimension means the width, how long the width, how long the length. So we can assume if the width is shorter side is x feet, then the length will be 100 divided by 2, it's 50. Because this is x, this is x, is 2 of it. And this is length, the two lengths are equal. You got 100, so this length and the width add together should be 50 divided by 2. And this side, the two sides add together also 50. So 100 divided by 2, you got 50. If you assume this side is x, then the length is 50 minus x. And this is x, this side is 50 minus x. If you add together, those x cancel, and you got 100 feet. That's the fencing. the length of fencing, total 100 feet. So you will do 100 divided by 2, get 50. And assume the width is x. 50 minus x is the length. And the area is length times width. So we figure out the area function. A of x equals the length is 50 minus x times the width times the x. Tying together. And use the distributive property to remove the parentheses. So x times negative x, we put negative x squared. X times 50 plus 50x. And question asks you what is the largest. So one, you can use second derivative test to get x, make largest area. Use second derivative. So you first of all you find first derivative on area function. You got first derivative is a negative 1 times 2 is a negative 2x plus 50 times 1 is a 50. And let the first derivative equal 0. Get critical number is x equal 25. X equal 25. And the 50 minus 20x minus 25. You got the length also 25. And this one is a maximum. You can use second derivative test because when you take second derivative of x from here, first derivative times second negative 2 equal negative 2 times 1. X to 1 minus 1 is x to the power 0. So it's a negative 2. Negative 2 is always less than 0. So this number 20x equal 20 from first derivative equals 0. You got x is 25. Plug into the second derivative is negative 2 because it's always constant, negative 2. It's less than 0. If less than 0, then this is a relative maximum at x equal 25. So when x equal 25 has a maximum area, check by second derivative test. You can get when. So we checked x equal 25 is relative maximum, which is this area is a maximum area. Question asks you what's dimension. Dimension means length and width. So x is the width and 50 minus 25 is the length. So dimension is 25 feet by 25 feet. So actually it's a square. Square is always the largest area. And what is the area? Tying together 25 length times width, 25 times 25, 625 feet square is maximum area. Question 8 about the volume. The volume here we call by cutting away identical square. Identical means equal square from the four corners of a rectangle. Identical means they are the same area of the square. Same area of the square. This identical, equal squares from each corner of a rectangle piece. This rectangle piece, four corners, each corner cut a square, and those four squares are identical. That means equal units, equal area of cardboard, and folding up the resulting flaps. Folding up. So after cut it, you fold up, then you form a box, open box. The cardboard may be turned into an open box. On the top, there's no top, have bottom, no top. If the cardboard is 15 long, That means from here to here, the cardboard is 15 feet long, 15 inches long, and 8 inches wide. So from here to here is 8 inches wide. And then find out the dimension of the box that will yield the maximum volume. So this is a box. After you cut, so we can assume this rectangle corner, 4 corner each, the square, one side is x, another side is x. This square is a square, so each square, the side of the square is x. The side of is x. So after you fold up, you folding up, then become this. Become the bottom, and with and this side is x. Become this. And become a box, an open box. And that's x. Then what's this? What's this? So this, because total is 8, minus x minus x minus 2x. So this side should be a minus 2x. This side. And then this one, total, the cardboard length is 15, and you minus x minus x. So this should be 15 minus 2x. So fold, and then you fold up. This side should be 15 minus 2x. So this box, the length is 15 minus 2x. The width is a minus 2x. The height is x. And the length times width times height is the volume, V. So we got volume in terms of x. V of x equal to 15 minus 2x times a minus 2x times the x. This 15 minus 2x times a minus 2x times height. Length times width times height is the volume of this box. That's the volume of the box. We want to find out the dimension to make this volume maximum. In other words, we need to find out what's x. Make volume v of x, function value, maximum. And you can use first derivative test or second derivative test to figure out the relative maximum value. Let's try. First of all, we have to figure out, we have to multiply out the function. You do 15 times 8, 120, minus outer term product, inner FOIL, by FOIL method. F is a first term product, O means outer term product, I means inner term product, L means last term product. So first term product, 15 times 8 is 120. Outer term product is a negative 30. Inner term product, 2x times 8, negative 16x. Combined is a negative 46x. Plus last term product, negative times negative become plus. 2x times 2x is a 4x squared. Parenthesis times x. X is the height. So this is length times width, and then times height, x. X distributive in. X times 4x squared is 4x cubed. X times 4 minus 46x become minus 46x squared. X times 120 is a plus 120x. So after multiply out, then you take derivative on v function. Take first derivative. 4 times 3 is 12. 3 minus 1 get 2. 46 times 2 is 92. X to the power 2 minus 1 get 1. 120x to the power 1. So it's 120. And let first derivative equals 0. solve for the x. So you let 12x squared minus 92x plus 120 equals 0. Simplify it. You can divide it by 4 each term. Common factor 4. 12x squared divided by 4, 3x squared. 92x divided by 4 is 23x. And 120 divided by 4 is 30 equal 0. Then factor it. Factor this because this is a quadratic equation, you factor it. So first of all, you factor 3. 3 is 3 times 1. Factor as 3 times 1. Then you factor 30. You can try many errors. Try until you get right one. Let's try factor this. 3x squared minus 23x plus 30 equals 0. First of all, 3, you can put 3 times 1, put on the first column. And 30, you can try many. You can put 1 times 30, or -1 times -30. Or you can try 2 times 15, or -2 times -15. Or next 3 times 10, or -3 times -10. Next 4 is not divided evenly. It's not a factor. Then 5. 5 times 6, or -5 times -6. Then next will be 6. And if you use 6, you go back to 5. Become repeating. Once you got repeating, you stop. Those all the after factors, all the combinations of factors of 30. Now then you put here. For example, if I put 3 and 10 and cross multiplication plus 30, 3 times 10 is 30, 1 times 3 is 3, add together 33. But we want -23. We want -23. So you try others. Like you can try 3, 1, cross multiplication like -5, 6, -5, -6. Oh, probably that one, right. 3 times -6 is -18, -5 times 1 is -5. Add together, -23. That's just external coefficient. That's correct. Attach with x. Because 3 times 1 comes from x squared, separate. X squared separate, 1x here, 1x here, attach. Put the parentheses and get the factor. So factor after factor will be 3x minus 5, 3x minus 5, 3x minus 5 times x minus 6. Over here, parenthesis 3x minus 5 times parenthesis x minus 6 equals 0. So this fact, and you can check it. 3x times x, 3x squared. Outer term product, -18x. Add inner term product, -5x combined is -23x. Last term product, -5 times -6 is +30. They are equivalent. So this is the factor of this quadratic equation. Then either first factor 3x minus 5 equals 0, or second factor x minus 6 equals 0. Then you this move 5 over, divided by 3, you got 5 over 3, or 6, -6 move over, get 6, or x equals 6. Then you have to check the 2x. Then which one is? If you plug this 6 into here, into a minus 2x, this side becomes negative. That's impossible. So 6 is not. If x equals 6, if you plug it in here, this side is negative. The width of box is negative. The width of box should be positive. So x equals 6 is not in the real world solution, not in the real world. So we use x equals 5/3, which is cut each corner 5/3, and fold up, form an open rectangular box. So each corner cut 5/3. And put 5/3 divided, 5 divided by 3 got remainder 2. So it's 1, quotient is 1 and 2/3 if you put mixed number. Then you figure out what is the width, what is the length. Figure out a minus 2x, a minus 2 times 5/3. 2 is 2/1. 2 times 5 is 10. 10/3. What is 8? Is a/1 times 3 both sides. Got 24/3. 24/3 minus 10/3 is 14/3. And divided. Get quotient is 4, remainder is 2. 4 and 2/3. Let's put in mixed number. Then figure out the length of the box. 15 minus 2x. 15 minus 2x is equal 15 minus 2 times x is 5/3. 2 is 2/1. So then you got 15 minus 10/3. The denominator is 3, so this 15 is 15/1 times 3 both sides. Got 45 minus 10, got 35/3. 35/3 divided. Quotient is 11, remainder is 2. 11 and 2/3. Then you put down the answer. You can answer in improper fraction, each one improper fraction, the length, then width, then height. Or you put it in mixed number, either way. That's a dimension. And you have to put the units, inches. Because here say maximum 15 inches, 8 inches. So put this in inches. Then what is their maximum volume? Maximum volume will be length times width times the height. So 35/3 times 14/3 times 5/3. Time together and put it in mixed number in inches cube. That's the maximum volume. It's question 8. Then next one. Question 9, we totally have 14 questions. Question 9. Question 9, it's more company requires that its corned beef hash containers have a capacity of 16 cubic inches, have the shape of right circular cylinder. Right circular cylinder. The volume is 16 cubic inches and be made of aluminum. Determine the radius dimension for right cylinder, which is the radius and height of the container that requires the least amount of aluminum, aluminum. So right circular cylinder, it's going to be circular, circle on the top, and on the bottom also circle. And right circular means the center on the top and the center of the bottom, if you connect it, will perpendicular down to the base. Perpendicular down to the base. And this is the height of each of right circular cylinder. So base area times height is going to be the volume of right circular. Circular means the bottom and the top, both are circle. Right means this height just perpendicular down, go through the center of the top and the bottom, and perpendicular down That's the height through the center of both bottom and the top. Is right circular cylinder. This we call cylinder. Volume. The volume is base area times the height. What is base area? Base is a circle. Circle area is a pi radius square, pi r square. That's the base area times height. Times height is the volume. Is the volume of right circular cylinder. Then we do question ask you find the radius and height to make minimum least amount of metal. That means we are going to make this right circular cylinder. We need the metal to make this surface area. That surface area is a minimum amount. What is the surface area? Surface area is the bottom area is pi r square. The top area also pi r square. Add this lateral surface. What is the lateral surface? Once you cut it and expand it, it's become a rectangle. When you cut this and open it, that becomes rectangle. This side is height, and this is 2 pi r. Circumference of circle is 2 pi r. So this lateral surface, this we call lateral surface area, is around this cone, around this container, is this area. This side is height. This circumference of circle is 2 pi r. And then length times height. So it's 2 pi r times h is this lateral surface area. Then add together is the surface area. So pi r square at pi r square is 2 pi r square at 2 pi r h is surface area. So volume is base area. Base area is circle. Circle area is pi r square times height. This is the volume of a right circular cylinder. Here given volume need to be 16 cubic inches, so equals 16. Then you can from here you can write h in terms of radius r square divided by pi r square both sides. Divided by pi r squares both sides. Get h equals 16 over pi r square. Then surface area is pi r square at pi r square because the top is pi r square, bottom is pi r square. The circle area, twice of circle area, plus lateral surface area 2 pi r times h. Then h is this one, plug in h. Then you will get the surface area in terms of r, radius, in terms of radius, r. So here is not x, it's r. You got the surface area in terms of r. So it's 2 pi r squared plus 2 pi r times h. H is 16 over pi r squared. Substitute in. Cancel pi. Cancel 1 r. Remain 1 r on denominator. 2 times 16 is 32 over r. And put r, move up. Put exponent -1. Negative exponent rule. So get this surface area in terms of r, radius. Get this function. Then want this surface area minimum, least amount of aluminum, of metal, which is this surface area. We want figure out the radius and the height. Make the container requires least amount of metal. So that surface area function need to be minimum. Find out the minimum. Find out R. Make this surface area function minimum. So we can use either we can use first derivative test. We can find out the first derivative. So S prime of R equals 2 go from 2 pi times 2 is 4 pi R, 2 minus 1, so R to the power 1. Negative 1 times 32 is negative 32 R. Negative 1 minus 1 is R to the power negative 2. And let this first derivative equals 0. Solve for R. Get critical number. So it's 2 pi R minus 32 R negative 2 equals 0. So it's 2 pi R minus 32. R to the power negative 2. Bring down to the denominator is R squared equals 0. Then this is 1. You times R squared times R squared both sides. And get same denominator is R squared. Numerator is 4 pi R times R squared is 4 pi R cubed. Minus 32. Denominator is R squared equals 0. And 1 divided equals 0. So numerator equals 0. So we got 4 pi R cubed minus 32 equals 0. Solve for R. Move minus 32 to the right. And get 32 over 4 pi. Cancel 4, get 8 over pi. Take cubic root. 8 take cubic root is 2. And denominator is the cubic root of pi. Cubic root of pi. And this one is relative minimum. You can check it. You do second derivative test. This first derivative, take derivative, got 4 pi. And the negative times negative 32 is positive 64. R to the power negative 2 minus 1 is negative 3. And then you got 4 pi plus 62 over R cubed. R cubed. And you plug it in. 4 pi plus 64. This is 1 over R cubed. This R cubed, it's 2 cubed. It's this one. You plug it in here. You got 64 times this R cubed. Reciprocal. This is R cubed will be A over pi. A over pi. It's positive, always positive, because this always positive, greater than 0. Since positive, make second derivative positive is a relative minimum. So R make this original function relative minimum. So it's a surface area minimum. And that's radius. That's the least amount of metal. That's R. Then you need to figure out H. H is H equals 16 over pi R squared. R is 2 over cubic root of R of pi. Square it. So equals 16. Denominator is a pi. 2 squared is 4. And this reciprocal, so 2 squared become on the bottom 4 on the denominator. Cubic root of pi squared on the numerator. And cancel 4 and get 4 on numerator. And the cubic root of pi squared over pi. Pi, you can write down cubic root of pi cubed, because the cube and cubic root is just pi. And both are cubic root. Divided, cancel, become pi square over pi cube. Cancel pi square and remain pi on the denominator. So it's 4 cubic root of pi. It's a height. Actually, is a radius doubled. 2 times 4 get height. So radius is 2 over cubic root of pi inches, because here say cubic inches. So it is in inches. The height is 4 over cubic root of pi inches. You can leave answer with pi. Or you can go decimal. Divided, use calculator, figure out cubic root pi and divide it by 2. 2 divided by cubic root of pi, you get decimal in radius and height. Height actually is twice of the radius in this case. Then question 10. Also optimization questions. A pencil cup with a capacity of 36 cubic inches is to be constructed in the shape of rectangular box with a square base and an open top. The base is a square, like this side is x, this side also x, is a square base, and the open top